At this at this point, we are going to learn how to find the domain of rational functions. Okay, this should be case 5. Okay, should be case 5. Domain of rational function. Okay, case 5. Now let's take the first question here. That says what is the domain of f of x of the function x minus 2. Now, for a rational function as this fraction to exist, the denominator should not be 0. That is to say that for this function to exist, x minus 2 should not be 0, which implies that x should not be 2. What it means is that x can be any other value, any other real number, but x cannot be 2. Now, if I show this on the number line, okay, if I use the number line to show this, what this implies is that x cannot be 2, but however, x can be any number between 2 and infinity and negative infinity. X can also be any number between 2 and positive infinity, which means from 2 and bigger numbers, okay, above 2 and bigger numbers could be x, below 2 and lesser numbers could also be x. All right, so it means therefore that my domain therefore in conclusion should be from negative infinity, okay, and I'm going to still use parentheses for this, union from 2 to positive infinity. All right, so x cannot be 2, but x can be any real number. Okay, so it means I can also say that x is any real number except x is not equal to 2. You could also write the domain in this form. Okay, it means the same thing. This is for the first question. All right, now the same idea can be used to resolve the second question. Let's do the second question now. That tells us to, for the second question, the function is f of x is equal to x minus 1 over x plus 5. Now, we are still having the same rational function here. Now, for the function to exist, x, the denominator x plus 5 should not be 0. That's what it means. So it means that x should not be minus 5. Any other number except minus 5 can go in, okay? So it means that I can say, if I draw my number line here, this is minus 5, this is negative infinity, this is positive infinity. Any number that is above minus 5 can be the domain. Any number that is below minus 5 can also be the domain. So therefore, it means that the domain can be any number between minus 5 and negative infinity. Okay, the domain can be any number between minus 5 and negative infinity, but not equal to minus 5, remember? And that was what we mean by union. It can be between minus 5 and positive infinity. Okay, so this is the domain. The domain can be between minus 5 and positive infinity. That is between minus 5 and bigger than minus 5, or between minus 5 and bigger than minus 5, or between minus 5 and lesser than minus 5. Okay, this is the domain of the function. 3x minus 8 divided by x squared minus 9x plus 20. Okay, now in the same way, this is a rational function. The denominator cannot be 0. So it means I can say from here that for this function to exist, x squared minus 9x plus 20 cannot be 0. Now, what are the factors? This is a quadratic equation, so we have to factorize it. What are the factors here? The factors here should be minus 5 and minus 5. So if I factorize this equation of having x squared minus 5, okay, no, factors are minus 5 minus 4. So if I factorize this equation, we having minus 5x minus 4x plus 20 should not be 0. Now this means x is common here, x into x minus 5. Okay, so minus 4 comes out, x minus 5 should not be 0. That implies that x minus 5 into x minus 4 should not be 0. This implies that x minus 5 should not be 0, or x minus 4 should not be 0. That is to say, x should not be 5 or x should not be 4. X should not be 5 or x should not be 4. Now, let's test what we have here. Okay, let's test what we have here. Now, any number aside 5 and 4, okay, we have to verify, okay, before we conclude, right? Now, when we draw our number line, this is our number line, okay. Now we have, let's say we have here 4 and we have here 5, okay. Now we have to check to be sure the domain. Now let's see for numbers between negative infinity and 4. Let's try 3. To place 3, this should be 3 minus this. 3 minus 5 is minus 2. 3 minus 4 is 1. It is not equal to 0. Okay. If I try 3, we have 3 minus 5 times 3 minus 4. We have minus 2 times minus 1. This gives us what? 2. So it is accepted. Okay, because it didn't give us 0. Should any number except 0 be accepted? Now let's try again. Let's try between 4 and 5. Between 4 and 5, we can have let's say we have between 4 and 5. Let's say we have 4.5. Let's use 4.5 for instance. I try using 4.5 here for instance. I'll be having 4.5 minus 5 into 4.5 minus 4. Obviously, the product between these two does not give me 0. So this guy is also accepted. Now let's try above 5. Let's see what happens. Above 5, let's see 6. 6 minus 5, 1. 6 minus 4, 2. The answer gives you a number that is not 0. So this guy is also accepted. Alright, so therefore I can say in conclusion, the domain should be negative infinity to 4 union 4 to 5 union 5 to positive infinity. Okay, so this is the domain. All right. Okay, now we're going to the next question. Into the next question. The next question that says f of x is equal to square root of x minus 4 divided by x squared minus 25. Okay. Now, something you have to understand here is that this type of rational function is quite different. You can see very clearly that at the top here we have the square root. Okay, we have a square root, and at the bottom here we have a quadratic function. Okay, so first of all, since we have a square root here, it means we have to include in our analysis, we have to include the numerator. I remember once we have a square root, since it's a square root, I've taught you before that it cannot be negative. What is inside the square root cannot be negative, which means that x minus 4 should be greater than 0. But however, if we have 0, is it going to be defined? Yes, square root of 0 is 0. So it could be 0. So I can add or equal to 0. That's the first thing I have to do here. So which means that for the numerator, x should be greater than or equal to 4. However, let's go down to the denominator. For the denominator, remember that x squared minus 25 can be written as x squared minus 5 squared. This is difference of two squares, which means that we can say that this is the same thing as writing Difference of two squares tells us that x plus 5 into x minus 5. Alright? So I can say that since we said that x squared minus 25 cannot be 0, it means that x plus 5, after expanding this guy, x plus 5 into x minus 5 should not also be 0, which means that x plus 5 cannot be 0 or x minus 5 cannot be 0, which means that x cannot be minus 5 or x cannot be 5. So at this point in time, I think I can wipe off this side. So from our number line, we'll make our final conclusion. Okay. So what we have here, remember we have 4. Okay, let's write down everything we have. Okay, and select. We have 4. All right. We have 4. We start with there's minus 5, so we start with minus 5. Minus 5 here. Then 4. 3, 4, 5. So now let's see if if we pick a number between minus 5 and minus infinity, is the function still going to be defined? Let's see. If we pick minus 5, is this function going to be defined? Let's see. Now let's say if picking minus 5 will make the function defined or undefined. Let's see that. Now if I put minus 5 here, minus 5 minus 4, there's a negative here. Already, the function cannot be defined because minus 5 minus 4 gives us minus 9. There's square root of minus 9 is undefined. So that rules it out. If I place minus 5 here, minus 5 squared is 25. 25 minus 25 is 0. So minus 5 cannot be a domain. Then now let's see less than minus 5. Let's see minus 6. Let's see what happens. Minus 6 minus 4 is minus 10. The function is already undefined. So this means that I cannot pick any number from between negative infinity to minus 5. It is out. However, let's check for between negative 5 and 4. Between negative 5 and 4, let's check. Now, let's say negative 4. Let's use negative 4. Or let's use 0. Any of them. If we use negative 4 or 0, let's see. Let's see negative 4 here. If I put negative 4 here, okay, this will be negative, negative 8. If I pick negative 4, I'll be having negative 4, negative 4, and that gives us negative 8. Negative 8. Now, negative 8 under a square root is not possible, it's undefined. But negative 4 here gives us negative 4 squared. That gives me 16 minus 25. The bottom, the under or the numerator, is going to give us a number that is not 0. But what rules this side out is the fact that I cannot use a negative 4 here. I cannot use any number between this minus 5 and 4 will make this function undefined. So this guy is out. Now let's check down from between 4 and 5. Let's start with 4. If we place 4 here as x, is the function going to be defined? Let's check that. 4 minus 4, 0. Square root, is it possible? Yes. So it satisfies for the numerator. Come to the denominator. 4 squared minus 25. 4 squared is 16. 16 minus 25 gives us a value. Right there. It gives us a value and it gives us minus 9. Okay? So it means if I place x as 4, the function is defined. The function is defined. That tells me that 4 can be chosen. Okay, let's see. Can 5 be chosen? Let's see if 5 can be chosen. Can 5 be chosen? Obviously no. Do you know why? Although 5 minus 4 is 1, top is satisfied, but the bottom 5 squared is 25. 25 minus 25 is 0. 0 cannot be here. The bottom cannot give you 0. So 5 is out. But how about in between 4 and 5? How about in between 4 and 5? Is it possible? Let's see. Let's see 4.5. 4.5 minus 4, 0.5. Satisfied because square root of 0.5 is defined. 4.5 here, 4.5 squared minus 25 would give us a defined value. So it means that between 4 and 5 is selected, but it has to start from 4. So it means that if I wanted to write the domain, I'm going to do something like this. I'm going to use a bracket for 4 to 4 to 5. Yes, because it exists. 4 to 5. But when it gets to the 5, I'm going to use a parenthesis. Now let's see if between 5 and infinity is possible. Okay, let's say 6. 6 minus 4, 2. Square root of 2, very possible. 6 squared, 36. 36 minus 25, very possible. So it both the top and the bottom is defined. So it means I can also use this guy. But however, it cannot be 5. So this will be union, then the parentheses, 5, and positive infinity. This, therefore, is the domain.